Hi, in this lesson, we'll take a look at header files. Let's get started. As you've seen in your programs thus far, importing libraries is a key part to each program. Libraries allow you to extend the functionality of C++. The libraries you have used so far have been internal libraries. In this lesson, you're going to look at the steps to create and use your own libraries. Creating a library in a header function is as simple as creating any other code in your program. When the file is imported into your program, the code from your header file is essentially written into your main program at the import statement. When you write functions in your header file, you have access to these functions as if they were in your program. Since your header file may be imported before other import statements, it is important to include imports in your header file that would be necessary for the code in your header file. For example, if you have a function in the header file that reads from the console, you need to include the IOStream library in the header file. Importing a header file library and using it is very similar to how you import a standard C++ library, such as vectors or IOStreams. The biggest difference is that the library name is enclosed in quotes. For example, if you have a random number library with a header file called random.h, any program that wants to use the library would use this include statement, #include in quotation marks random.h. Once imported, you can then call a function as if it was in your program. Let's look at an example now. When we want to use a header file import, we may not always want to know which imports are included in the header. Notice here that we import a few things a second time, but it does not cause an issue in this case. As you can see down here, this is the header file import, and here's our header file over here. Notice how we have IOStream here and IOStream here. This won't cause an error in our program though. Notice that we can reference the readline function as if it was previously defined in our program. Here's the readline function right here, even though we've never defined it before, except here. And here is the readline function. This is what happens when we run our code. As you can see, the code works just as well as it would as if we wrote the input.h file in our main function. While defining functions inside a header file can be common for a small library, most libraries are implemented using a combination of a header file and an implementation file. The header file generally contains function prototypes and import statements needed for those function headers, and the implementation file then carries the function definitions. The split is generally done so a developer can look at the header file to understand how to use the library, but doesn't need to get into all the details of how the functions are implemented. Implementation files have the same root name as the header file, but carry a C++ extension of .cpp. As you can see in this example below, the file name for the implementation file is input.cpp. The header file would be called input.h. The implementation file needs to import the header file and any additional import statements needed for the function definition that were not imported in the header file. If they're already in the header file, then you don't need to include it in the implementation file. Here is some code from our original header file. Now we're going to split it up into a header file, and an implementation file. Here's what it looks like when we split up the original header file into a header file and an implementation file. Notice how the header file is now more streamlined and provides information that is needed for a developer to use the library. The implementation file, on the other hand, now separates out the details for how the function works. The implementation file needs to include the input header file, but doesn't need to include the IOStream again. Remember, to use the library, you only need to include the header file. You don't need to include the implementation file. Let's look at another example. As you can see, this is the same example from last time, but the header file is split up into a header file and an implementation file. You can see we have the streamlined prototype right here and all the details of the code right here. If we run it, it will run just the same as it did before. As mentioned earlier, using a header file is like importing the code from the header file into your program. Just like any C++ program, you cannot define the same function twice, so you need to be careful not to define a function with the same function header as one in the library. This will cause your program to error. Importing the same library more than once will actually cause the code to fail. While end users of the library may not specify to import the exact library twice, some libraries may still get imported twice since one library may use another library. A good example of this is the IOStream library's use of string library. If you didn't know that the IOStream library included the string library, you may end up importing the string library a second time. Fortunately, there is a process that you can use in C++ to protect your code from multiple imports. C++ has a set of terms collectively known as inclusion guards. They are used to protect against multiple inclusions of functions. The first one is if and def, and it checks to see if token name has already been defined. If it hasn't, the program continues. The second one is defined. Here, you create a token and then execute the block of code below it. Then, at end if, the block is ended. If the token was previously defined, then this is where the program will skip to. If a define was used, it will end the definition block here. A token name can be anything, but it is typically something similar to the header file name. These safeguards only need to be included for the header file and should enclose the entire code. Let's take a look at an example below for split.h file. Notice in the example that the token was named split.h, but it could be named anything. In plain English, the flow of the program is to say, if split.h has not yet been defined, then define it now. If it has been defined, then skip to the end and do nothing. Now, let's take a look at an example. In this file, we are including both the split and input libraries since we need both. As you can see, they're right here. However, if you look in the modified input header, you will see that it also needs the split library. If we go on here, you'll see that we import split. However, C++ doesn't like it when you try to import the same external library twice, so we need to have a control for that. Let's take a look at the split file. Down here, you can see that we have inclusion guards. These inclusion guards help us to check if the function has already been defined. As you can see, when we run our code, everything works great, even though we try to import the input file twice. This is what happens, though, when we comment out our inclusion guards. We get a huge error because we've inputted it twice. See, we have split line right here and split line right here, which we don't want. But if we bring them back, it will check if we've imported a function twice and will stop it from being imported twice. Now that you've learned about header files, implementation files, and inclusion guards, it's your turn to get some practice in the CodeHS editor.